Yep, we are all set.
All right. So good afternoon, everyone. Since it's past 12 o'clock, welcome to today's session where we are going to talk about elastic computing with Salesforce functions. My name is Aditya, as he has already introduced. I work as a developer advocate at Salesforce, and my primary job role is to connect you with all of the great content that is out there and help you be successful. You can follow me on LinkedIn as well on this handle Adityanak3, and of course Twitter. He already said he shared it with you. So now that there is a Twitter contest, this entire slide deck is going to be on Twitter. Let's not have that, as he mentioned. We don't want all of these slides to be there. Only whatever is relevant. So before that, the forward-looking statement that says, please don't make any purchasing decisions based on whatever I might say today. Please make it based on generally available information that is publicly available about a particular product. And today we are going to be talking about functions. So please ensure that you are talking to your account executives about the latest offerings and only then make your purchasing decisions. So I am a part of the developer relations team, and as I mentioned, our job role is to connect you with all the great content. And one of the primary ways in which we want to do that is using Telegram. So if you're not already a part of this Telegram channel, please join it. So it's an official channel that is run by our team, and we keep posting all the latest news and updates. Any events that we do, you'll be the first ones to get to know that information. You can network with others, and we also run weekly trivia quizzes, and you get a chance to win some goodies as well if you participate in those quizzes. So we pick one winner each month. So make sure you participate in the quizzes to win fun prizes. Of course, other than connecting with me, you can follow our broader channels. So because it's not just me who's going to deliver this content, it's going to be my colleagues as well, like Satya, Philippe, Mohit. Most of them you already know about. Um, so without further delay, let's look into the agenda. So today we are going to cover what is Salesforce Functions and how you can get started. And within functions, there is something called as the Salesforce SDK. We are going to look at what it is, and then we are going to look at a very small demo, after which we will open for Q&A. So given that this product is not new, functions has been around for quite some time. I'm assuming some familiarity. If not, also this session will be equally helpful. But I'm not going to dive too deep into any of the topics, because it will take a lot of time to get into each one of them. But I'll give you a very high level overview, which will be good enough for you to get started with functions. So before going and talking about Salesforce functions, let's first understand what is a function. And this function is not your typical function that is there in your JavaScript or Apex code. So similar to the cloud infrastructure, like infrastructure as a service or platform as a service, there are new offerings that are coming out, which is called as a functions as a service. So in the term functions as a service, what is a function? It's really the statement on the screen. It's a single purpose, on-demand, short-lived microservice without complex infrastructure. So there are a couple of words here. So first word is single purpose. So as it is self-explanatory, a function, it serves a particular single purpose. It's not meant to do everything under the world. It does it is built for a particular thing, and it does that particular thing very well. So let's say you want to generate a PDF. So you create a function for generating a PDF. So that's the purpose of that function. The second word here is on demand. So typically, the way web servers work is that the server is running all the time, and whenever a request is made, the server returns a response, and all the other time it is just sitting there waiting for a request to come in. And that's typically how a web server works. But in the case of functions, it is all on demand, which is that only when you invoke a function, computing resources are used, and it processes your request and returns a response. And once that response is delivered, the computational resources are released, which means it's not taking up any idle time. It's only working when it is working. So that is what is on demand, and it is short lived. So a function, like I said, it's not a web server that is going to run 24 by 7. A function is only going to run on demand whenever it is invoked, which is why it is very short lived. So let's say your function runs for 15 minutes, and after that 15 minutes, your function execution is done. That's it. That's all the function is alive for. After that, all the resources are released, and the function no longer exists on the server. I mean, it does exist as a code snippet, but the runtime itself is not going to be there. And because of all of these nuances, it doesn't require any complex infrastructure to deploy. You need to just have like a runtime, and then the server is and your function is going to run. Now, this is typically the industry definition of what a function is. Now, within Salesforce, so other than Salesforce, functions have always been around for quite some time. On AWS, you have Lambda functions, and Azure has its own version of functions. Netlify has also come up with its own version of functions. So functions has been around, and it is around in all the other technologies as well. So within Salesforce, or what we are calling it is Salesforce Functions, which is going to be our very own functions as a service offering. And the way it is going to benefit you is um, the same serverless infrastructure, the same microservices, the same architecture is what is going to be provided to you in order to run your functions. And the best part is that you can run it using any programming language of your choice, whether it is Node.js, whether it is Java, whether it is TypeScript or Python. It is up to you. You can decide. You need not just write your functions in Apex. So actually, Apex is not supported because Apex is a programming language on its own, which runs on Salesforce infrastructure. On the server, on the functions infrastructure, you can run it using Node.js, Java, and Python. Now, is it only that makes functions great? Question. You can already do this with Salesforce. You can host it on a third-party service, and then you exact same things. But what makes Salesforce functions great is advantage you can see immediately is that you are within the trust boundary of Salesforce. That means your functions are tightly integrated with the Salesforce infrastructure, which means you need not have to worry about authorization and authentication. It is already set up within a function, so you don't have to do it explicitly. So the function runs within the same trust boundary. It knows who the user is, it knows your security context, it knows your org information, it knows everything about your org. So you need not set up a specific authorization like JWT or web server flow. All of that extra setup is not required. And it is elastically scalable. So the title of the session says elastically scale with Salesforce functions, and this is where it comes in. So typically with Apex running on the Salesforce platform, you have certain limitations in terms of governor limits, in terms of runtime limits, and those limits are relaxed when it comes to Salesforce functions. So you're not like stuck to the 6 MB heap size, or let's say a 2 minute or 120-second transaction. So those are the limits that will be relaxed for you. And these functions can scale based on the demand. So let's say your function is receiving less number of requests right now, so the resources allocated to your function will be minimal. But if suddenly there is like a sale going on your website and your function gets invoked a lot many number of times, we automatically scale the infrastructure so that your function doesn't go down and it is able to serve all the number of requests that are coming in. So that scalability happens automatically behind the scenes. And because you're working with industry standard programming languages like Python, Node.js, Java, it is easier to find developers who are outside the Salesforce ecosystem as well, to get them in and start building your functions within Salesforce. So you typically have like an expanded talent pool is what we call it, because it's not just Salesforce developers, but any developer in the broader IT ecosystem can now start building stuff on Salesforce using the programming language of their choice. Now, what are the use cases for functions? Is it going to be used for each and every use case that you have? Does it mean you'll have to stop writing Apex and only use functions? No. So there is like this decision chart that you can use to decide if functions is relevant to you or not. So for most use cases within the Salesforce ecosystem, you can get away with using Apex, and that is what we recommend. But there are a few instances which, let's say, need more processing power. Let's say you're working with tons and tons of data and you need to perform complex calculations on that data. And typically, if you want to do that in Apex, let's say it's going to take 3 or 4 minutes. Obviously, Apex doesn't allow you to do such computational heavy tasks, which is when you'll have to go with using Salesforce functions. So the first point in decision is, do you need more processing power? If yes, go with functions. If you don't need processing power, but you're pushing Apex to reaching its limits, then you'll have to consider whether you have to use functions or not. If your logic needs to run within the same transaction, you'll have to use Apex. But if you're okay with your logic running in a different transaction and you're pushing Apex to its limits, you can go with functions. So that's all the logic that you need to know. So be a little bit careful about deciding what are you going to use a function for versus what are you going to use Apex. Another very simple example is, let's say you want to make a call out. You can make a call out using Apex, you can make a call out using JavaScript, and you can also make a call out using functions. So just to make a simple call out, do you need to write a Node.js script and call that from Salesforce? Very unlikely, right? You're only going to have to make that call out within Apex. It's much more faster, it's much more performant that way. So that way, don't look at functions as a thing that will let you get around with limits. Use it only when absolutely necessary. So how do we get started with functions? First of all, functions is not generally available to all the orgs out there. You need to talk to your account executive and get it enabled on your org. Now, does it mean you need to have a license to start experimenting with functions? No, you can actually run your functions locally as well and test how these work. And then you can deploy them to Salesforce. And to deploy your functions to Salesforce, you need a license. To run your functions locally in your own org, or sorry, on your own desktop, you don't need to have a functions license. So typically, step number one, get started with local development, build your function locally, test your function, experiment with it, learn about functions. If everything looks good, then go ahead and take a trial version of functions, or you talk to your account executive to get functions enabled on your own org, and then deploy these functions to Salesforce and then use it in your own business logic. So that's typically the workflow that we recommend. Now, how do you learn functions? If I were to tell you, learn Lightning Web Components, one of the resources that you keep referring to is LWC recipes. In fact, the LWC documentation itself refers to LWC recipes a lot. So very similarly for functions, we have functions recipes with a bunch of different functions that we have created in languages like Java, JavaScript, and TypeScript. And you can use these in order to learn how functions work. And I'm going to show you some of these recipes today. Now let's look at the anatomy of a function. So I'm going to language because I'm
most familiar that the audience here
I'm
must
assuming because if you're sales, likely you're working with Lightning Web Components and JavaScript. So a function just looks like a function. If you see, it says async function, and it takes in 3 parameters. First is the event, second is the context, and third one is the logger. And all of your logic of the function is written within this function block. And these 3 parameters, let's look at what these 3 parameters are. The first parameter is event. So whenever you invoke a function, you can pass some data to it. So a function, like I said, is a microservice. It doesn't have any context, and it is serverless, it is stateless. So whenever a function is executing, you must supply all the data that it needs. So either the function can query all of the data on its own, or you can supply some data as an input when invoking that function. So you use all the data that you pass to the function is part of your event parameter. So within the event parameter, there is a data property. So event.data, that is where all of your data that you send when invoking a function is going to be present. Now the context parameter. Like I told you, a function runs inside the trusted boundary of Salesforce, which means it is already connected and authenticated to your Salesforce instance. Now, the context parameter is going to give you that context of the Salesforce org that it is connected to. So using this parameter, you can get the session ID, you can get the org information, you can query details, you can do your CRUD operations. So all of that can be done using the information provided in the context parameter. The context parameter also gives you the session ID that you can use further to call any APIs that you want. Any Salesforce APIs that you want, you can use the session ID and invoke those APIs. So all of that information is present in the context parameter. Finally, coming to the logger parameter, that helps you log statements. So just like console.log in your JavaScript code that you run in the browser, you'll have to use the logger function or the logger parameter to log some information for you to debug a function to see what is happening inside it. Now, for some Java developers who are there in the call, this is how a Java function is going to look, where we are going to implement the Salesforce function interface, and the apply function or the apply method is going to have all of the logic that your function has. And as you can see, it also has the three parameters, that is event, context, and the logger uses the standard Java logger instance. So pretty much you need to be aware about these logger, and based on this, you can start writing your own business logic inside this function. Now, functions can be invoked using your local development, that is locally using command line, I can invoke this function. But once you deploy this function to Salesforce, you can invoke it using Apex. And from Apex, there are two ways in which you can invoke functions. One is synchronously and one is asynchronously. So if you look at the logic over here, you can see in order to invoke a function, you need to first get the function definition or the reference to that function. So you write functions.function.get and you give the function's name. And then you invoke the function using the dot invoke and pass it a payload. So this payload is nothing but the data that you want to send to the function, which is going to be available to you using event.data property. So once you invoke a function, you can get its response and you can read the response and do whatever you want within your Apex class. So this is the way in which you synchronously execute it. So you call the function, you get a response, and then you look at the response. Now, what if the function takes about 15 minutes to run? So your Apex obviously can't wait for that 15 minutes. So you need to invoke the function asynchronously. So in here, it almost works the same way. So the first thing is you get the function definition. And when invoking, other than passing the payload, you also pass a callback method that gets invoked when the function finishes running. So these two statements execute synchronously, where your function is invoked. Think of it to be like a future method. Okay, so you invoke the function and there is a callback. So once the function finishes running, this callback is executed and your response is going to be available in this callback. And this part, this class, which is my callback, is the one that is executed asynchronously whenever a function finishes running. So these are the two ways in which you can invoke functions using Apex. Now, before we look at how functions are created and all, let me also tell you a little bit about the Salesforce SDK for Node.js functions. So a Salesforce SDK is provided to you as a wrapper for all the connectivity that you have with Salesforce, all the CRUD operations that you can do, any operation that you can do with the Salesforce data is provided to you within the Salesforce SDK, and it provides you a bunch of interfaces as a part of the context parameter. So the very first thing we can look at is the org interface. So you can get the information about the org to which your Salesforce function is connected to. So very simple. In the context parameter, you're going to have context.org, which has all of your org information. So you can do .id, .api version, .base URL, .domain URL. Whatever information about the org that you want to get is available to you as properties within the org interface. Now you can also get the user data. So typically in Salesforce, if you want to get the user data, you do user info dot get user ID, get username. So very similar to that. In here, you can do context.org.user. So the user property is a part of your org property. So in order to get the ID, you do org.user.id. Some other fields like username and all, you get the idea. There are properties available for you to get the fields of a particular object. Now, the important one here is the data API interface. So the data API interface, like the name suggests, it's going to help you do CRUD operations on the data present inside Salesforce. So the very first thing that we are looking at here is a query. So context.org, again, your context parameter, the org that it is connected to, and the data API interface to connect to the data. And what do you want to do with data? You want to query the data. So within that, you can pass any SOQL statement. So here you can see you have inner queries, you have where clauses, you have like all of the SOQL operations that are supported in Salesforce are supported here as well. Just pass in the query that you want and you are going to get the results. It's not just querying the data, you can create records as well. So here you can see that in the data API, you also have a create function. So you use create and then specify the details of what you want to create. So the type is going to be account or any object of your choice. And in the fields, you're going to have a key value pair, which is the name of the field and the value of the field. And you have create, update, delete available. Coming to the last part of the data API, you have what we call the unit of work interface. So within Salesforce, I'm sure all of you are aware about the transaction concept, where you do a bunch of operations in a transaction. And let's say if one of the operations fails, the entire transaction is rolled back. So that's how a transaction works inside Salesforce. You can use save points to control the transaction flow so that you don't roll back the entire transaction, but only roll back a few of them. So the same transaction concept is available to you in functions using a word called unit of work. So a unit of work is nothing but a transaction. So first, what you can do is you can create a new unit of work. And within this unit of work, you can do multiple operations. So here you can see I've initialized a unit of work and gave it the name UOW. And within UOW, I'm registering a create of an account. And on the next slide, I'm registering a create for a contact. I'm registering a create for a case. And I am calling data API.commit unit of work, and I'm passing the unit of work parameter. So within this one statement, all these three operations, that is creating an account, contact, and a case, are going to go through as a single operation. Now, if one of these things fail, the entire transaction is rolled back. Now, if you were to individually do create for each of these, like account, contact, and case, each of these would be three different operations. So if an account creation fails, the call to the contact invocation or case invocation would not go through, obviously, because account ID is missing, but the account, the rollback doesn't happen. So that is the concept of unit of work in order to create transaction control. Now let's look at a very quick demo of how you can work with functions within Salesforce. So make sure you are on the latest CLI version. If not, you can just run sfdx update and it's going to get in the latest version. Now, this is a typical SFDX project. All of you, I'm sure, are familiar. There is Force app. You have all of these different folders for the different metadata that your Salesforce org might have. In order to create a function, you can hit Command Shift P or use a CLI commands. Nobody wants to remember CLI commands, so let's create it using the command palette itself. So just like you have different options to create a Lightning Web Component, create a Visualforce page or Apex class, you have an option to create a function as well. So just choose create a function and enter a name for your function. Let's call it demo function. And you can choose a language. Right now within VS Code, we support Java, JavaScript, and TypeScript. So I'm going to choose JavaScript because I'm familiar with that. And as you can see, immediately it creates a function. And where does it create a function? So there is a separate folder called functions in your SFDX project. And within this, you have all the different functions that your project contains. So I've previously created these two functions, but right now I have created this function called as the demo function. And if you expand the demo function folder, you can see that it is a project on its own. So it's a Node.js project. The way you can tell that it has a package.json file and it has an index.javascript file which contains your function definition. So within the package.json file, you have a few dependencies. So if you are familiar with Node.js, you can install any npm package that you have access to and then work with that code within this project. So this is the basic anatomy. Now, in order to run this function locally, the first thing that you need to do is go into the functions folder and the folder in which your function is present. So like I said, it's a project on its own. So you need to be in that project directory in order to run the function. So because it's a Node.js project, you can do things like npm install, or if I think it's already run, let me try to run it again. So what this does is it installs all the dependencies that are there. And then if you want to run test scripts within this project, you can run the test scripts within the project as well. And in order to run the function, um, you need to run this command, sf run function start. So sf is like sfdx, which is a command line package that you can use in order to run the functions code. It's a broader part of our CLI unification effort. So sfdx is going to be there, sf is going to be there. SFDX only used to cater to your force.com projects, but SF we are building as a CLI installable that can cater to all the different products in the Salesforce ecosystem itself. So more information on that will uh, come out soon, and most of it is already present in the blogs, so you can go check it out. But just know that SF is also a part of your SFDX package. So the moment you run this command sf run function start, what it's going to do is it's going to create like a local runtime environment for your function, and it's going to start running your function within that local environment. And it's actually pretty quick. When we launched functions initially, it was a prerequisite that you need to have Docker installed, but now Docker is no longer required. This is a lightweight local runtime that we have come up with without the need of any third-party runtime systems like Docker.
Now that your function is
running,
you can invoke the function.
Now, to invoke a function, there is again a CLI script where you need to specify the endpoint on which this function is running, which is typically localhost 8080 or wherever it is running. But there's an easier way. If you have a payload that you want to send, which typically you do, because whenever you invoke a function, you'll have to send it a payload or some data. So you can create a JSON file for it. And whenever you create, VS Code is going to give you this nice little code action where you can just click on invoke. And what it's going to do is it's going to invoke the current function based on the data that is supplied over here. So at the moment we are running this function. So we quickly show you what this function contains. Just like you've seen in the presentation, it contains three parameters: event, context, and logger. And using the context parameter, I am using the data API interface and querying all the accounts that are present in my Salesforce arc. And then I'm using the logger parameter in order to log the results. So whenever I invoke this function using this payload, so ideally, as you see, we are not doing anything with the payload, but we are just logging it saying that we are invoking this demo function with so-and-so payload. So if you scroll and look at the output, you can see that all these results have been returned to you as a part of this query. So my org currently has 13 accounts, so it has returned all these 13 accounts to me. So this is how you run a function locally. And then once you're done running the function, you can actually quit the function and then it will stop running. So this is how you typically work with it. Pretty simple. As you can see, I don't have a functions license. I just have an org that is authorized so that it knows which org it has to get the data from. And then everything else I'm doing locally, even without any license. Now let's look at a different example. So what I'm going to show you is, hopefully this is logged in. So this is the functions recipes org. So whenever you install the functions recipes, there is a user interface that we have given you that shows you all the code for the functions that are there. Let's say there is this recipe for processing large data volumes. This is how a function that processes large data volumes typically looks like in JavaScript. And if you want a Java version of it, all the different files that are available is shown to you in the user interface. And from here, you can run the function as well. But in order to run this function, you need to have the functions license on this org, because this run function, it invokes an Apex method that calls the function. And like I told you before, if you are running a function locally, you don't need a license, but to run a function on org, you need a license. So you can install this recipes onto any org of your choice, but to run it in the org, you need a license. So that way, here is how the recipes is going to look like. But since we are doing things locally, let's look at recipes within VS Code itself. So first, let me show you one recipe in the context of TypeScript. We have already seen the data API query in a different example that I have shown you previously. So here, let's look at a TypeScript example. And those of you who are familiar with TypeScript, you know that a .ts file denotes a TypeScript file. And it's going to look pretty much similar to a JavaScript file, but it's going to have some additional type information as well. So here, you can see it's the same function, event, context, logger. And here what this function is doing is it is trying to print the org information. And to look at the output, again, you have to go to the command line, type in function run start, and you need to do this in the folder of the function. So here I'm trying to run the TypeScript function. So I go into the folder of the TypeScript function and I type in the command sf run start. Now what you see here, before the function has started, it has automatically built your TypeScript files. So again, those of you who are not familiar with TypeScript, generally the way TypeScript works is that before you deploy a TypeScript project, you need to build the project where all the TypeScript code is converted into relevant JavaScript code, because the browser in the end, or Node.js for that matter, doesn't understand TypeScript. It only understands JavaScript. TypeScript is just for your development safety and best practices. So before deploying a TypeScript file, you need to convert that to JavaScript file, and that automatically happens using the build process. In a normal TypeScript project, you'll have to manage that build process on your own. But within functions, the moment you run the function start, or whenever you deploy a function to the Salesforce org, we automatically run the build for you and deploy the relevant files. So again, in order to invoke this, let's go to payload.json and click on invoke. And then you can see that you are getting all the information that is relevant to the org that the function is displaying. So this is one of the examples that I wanted to show. These other recipe that I wanted to show you, I'm not sure if this is going to be too relevant because the same thing is covered in the next recipe. Let me show you the unit of work recipe actually. So it is the exact same code that I've shown you on the slide deck. So it's a function, and within the function, I'm trying to get the payload where I am getting the account name, the last name, and the subject, and I'm creating a new unit of work that is going to insert my account, contact, and case. So here within the unit of work, I register a create for the account, and then I register a create for the contact, and then a register create for the case. Now, what is important here is that whenever you're trying to insert a contact, you need an account ID. You can actually get this account ID from a reference to the previous create registered. So here I'm registering a create for the account, and I'm giving the name account ID for the result. So this is going to be the reference between both of these calls. So the account ID that's going to get created here is going to be passed into the next one, and the account ID and contact ID that have been created is going to be passed as inputs to the case. So similarly, I have created multiple cases over here, and I'm calling the unit of work at once. And whatever result I'm getting, I'm trying to print that result. So this is like a working example. Whatever I've shown you on the slide is a theoretical way in which you can do things, but this is like a working example of how you can use unit of work. So let me go into the unit of work and start that function. And within the payload, you can see that we have all the different fields that the function is expecting. Now, whenever I click on invoke, it's going to run the function. And you can see it's created the account ID, contact ID, and all of these successfully. Now, let's say I don't give the last name, and I only pass the account name, first name, and subject. And as all of us know, the last name is mandatory to create a contact. Now, when I try to invoke the function with this data, you can see that the invocation is going to fail, and the function is going to throw the error of please provide a last name. And this actually is going to roll back the account that has been created as well, so that none of this data is committed. So that's how the concept of unit of work works. Now, that was how things have worked locally. Now, how do you deploy functions to your org? The very first thing, like I said, you need to have functions enabled on your production instance. You can either reach out to your account executive for that, or you can request for a new trial org. So once you do that, you need to create what we call the compute environment. Now, this is a brand new concept, so let me explain. If you look at a typical SFDX project, it has your Salesforce code, which is all of these, and it has your functions. So all of your Salesforce code is going to run in a Salesforce org. So any class that you deploy, Lightning Web Component to deploy, it's going to get deployed onto a Salesforce org, and then it's going to run in that org. But when it comes to functions, functions are deployed to what we call a compute environment. A compute environment is an environment that is separate from your traditional Salesforce orgs, but at the same time, it is connected. So think of it like a subspace within your org into which functions are deployed. Now, the way compute environments work is that a compute environment is tied to an org, and it is tied to a project. So when I say project, it means your local project that you're working with. How do you know what is a project that you're working with? You will go to sfdx which is going to be present on all of your SFDX projects. And this is going to be the name of your project. In this case, it is going to be functions recipes. So a compute environment is a combination of both your project and a Salesforce org. And each compute environment is tied to a dedicated project. So from a project, you can only create one compute environment. So what it really means is a Salesforce org can contain multiple compute environments, and each of these compute environments is tied to one particular project of yours. So let's say project 1 has 3 functions, project 2 has 1 function, and project 3 has 1 function. So all the 3 functions in project 1 are going to be deployed to this compute environment. The functions of project 2 are going to be deployed into compute 2 environment. Project 3 to compute 3 environment. So this is how the concept of compute environments work. So whenever you run the deploy command from an SFDX project, you supply one parameter, that is the org to which your function has to be deployed. Now, since you're running this command from an SFDX project, this command already knows what is the project in which you're running in. So based on the project in which you're running in, and based on the org that you have specified the function has to be deployed to, the compute environment is automatically identified by the runtime. So you, as a developer, when deploying functions, do not control which compute environment a function gets deployed to. You only know which project you are running the deploy command from and which org you are running it against. So based on these two parameters, it knows which compute environment this function has to go into. So that's, I know, a slightly tricky concept, but just know that, let's say you're working on 3 different projects, like 3 different VS Code projects, and all of these 3 projects are connected to the same org. You'll need to have to create 3 different compute environments, one for each project. Now, let's take the same example and look at how it works whenever you're dealing with Scratch orgs. So you have a Salesforce org, which is like your Dev Hub instance. And this Dev Hub instance or your Salesforce Functions production org, whatever it is, the main org, is connected to a functions account. And this connection is inherently established whenever you activate functions in the org. Now, using the SFCLI, you are going to authorize to the Dev Hub instance. All of us have done this process in the past. You use SFDX auth web login, or using command palette, you run authorize an org. So it's going to authorize this Dev Hub instance to your SFCLI. Now, in order to deploy functions, what you also need to do is authenticate to this functions account. Now, under the hood, these both are different, but for you as a developer, the login credentials to both are the same. I mean, for you as a developer, you log into the Salesforce org with the same username and password. Your functions account also has the same username and password. It's just that because in the background, both of these are different, you'll have to run a separate SF login functions command, give the same username and password, and then the CLI is going to log in to the functions instance as well. Now, once you do that, you can create a Scratch org, and a Scratch org can have a compute environment, and this can be based on your projects. So similarly, if you have multiple Scratch orgs, you're going to have one compute environment for each Scratch org per project. So this is the way deploying functions works. If you have any questions, I'll be happy to answer them. But in order to create a compute environment, this is the command. So sfenv create the environment and the org alias to which your compute environment has to be connected to. So the compute takes some time, which is why I'm not going to run it in front of you. But so you're running this command from a project and you're specifying an org detail. So the compute environment that is created knows which project it is connected to and which org it is connected to. And you can list all the environments that you have using sfenv list. It's going to show you all the different Salesforce orgs that you have, Scratch orgs that you have, and the compute environments that you have. And if you notice, the compute environment here is attached to the project name and the org. Now, in order to deploy your function, you need to commit the changes and run the command sf deploy functions and specify which org the functions have to be deployed to. And that's it. Your functions are deployed. And then you can start invoking these functions from the Apex class. That I have shown you in the previous slides. Now let's actually look at a working example. So I'm not sure how many of you are familiar with this sample app called eCars that we have along with LWC recipes, functions recipes. The same repository has a sample app called eCars, where the use case is that it's a typical car showroom application. You choose a car that you want, choose an exterior color, choose an interior color, and then search the lead to which this car is assigned to, and then you save the configuration. And once you save the configuration, what we do is in the background, we invoke the Salesforce function, which creates a PDF. And this PDF is going to be attached to, I think, the lead record. So here you go, the car that we have chosen with the configuration. There is a PDF created for it using a Salesforce function. And here is the exact same PDF with the configuration that we have chosen. As all of us know, one of the most frequently asked use cases once we've migrated to LWC is how do we generate PDFs? What are the JavaScript libraries available to generate PDFs using Lightning Web Components? So to answer that question, PDF generation can be better done on the server, and you can use Salesforce functions to generate this nice little PDF. Now, to look at the code behind this function, let's go into the eCars org or the project right now. And you can see that here we have a function which is called the vehicle allocation processor. And in index.js, which is your function definition, you can see there is this definition here, event context logger. But I'm importing the PDF make npm library, which is one of the npm libraries that lets you generate a PDF. And there is a bunch of other stuff that I'm loading, like fonts, etc., that can be used within the PDF. Now, within this, what I'm doing is whenever I'm trying to invoke the function, I'm passing the vehicle ID and the lead ID as information. So the lead that has just been created is passed, and the car that they have chosen is passed. So I'm not passing the entire data. I'm only passing the IDs because the function has the ability to query all the other information it needs. So with the lead ID, it is querying for the name, email, and other details that the function needs. And with the vehicle ID, I'm querying all the interior colors, exterior colors, and so on and so forth. Now, once I have all of the data that I need from Salesforce, I'm going to use the Node.js library to create the PDF. And once I do that, I'm going to insert it into the database, into Salesforce. So here you can see I'm using the data API. And what I'm doing is I'm creating a content version, which is what is used to store files in Salesforce. And then I'm attaching it to a particular record using the content document link that you can see here. So I'm attaching it both to the lead record and the vehicle record. So I want both of these to be done in the same transaction. So if one linking fails, I want the other one to fail as well. So what I've done is I have inserted the content version in one transaction, whereas the content document link, I am assigning it as a unit of work because I want these two things to be inserted at once. And once I do that, I'm returning the information back to Salesforce. So this is how the function looks. Now, once I deploy this function, how am I invoking it? I'm invoking it using Apex. And in Apex, I've put this inside an invocable method because I want to call this from flows. If you want to call this from Lightning Web Components, you can do that. You can add the Aura enabled annotation over here. But within this, it's your typical Apex logic. Here, as you have seen previously, we are invoking a function. And as you can see, here is the function name, which is vehicle allocation processor. But you're also specifying the project name, which is eCars. So whenever you're trying to get a function reference, you'll have to specify the project name and the function name. Because I'm in the eCars project, I say eCars and the function within eCars. And then I invoke my function using the syntax that I've shown you in the slide. It's actually very simple. You just do invoke. And since this is not a very resource intensive operation, PDF creation takes like 2 seconds. So I'm choosing that I'll do this synchronously itself. So I'm not passing any callback function. And I'm getting the response back. So this is typically how a real life use case would look. whenever you are working with functions. Now, there are a few more things that you can do with Apex. So how do you find more information about functions in your compute environments? So there are a bunch of metadata objects in the background that are created that you can query using Sockle in order to determine many things, like let's say who deployed this function or who updated the functions. So there is a function reference object, and it's going to show you created by, last modified by, all of that is present over here that you can query. You can query the functions connections as well, that is the elastic compute or the compute environments that are there. You can query that. You can query all the different instances where the function has run. So let's say somebody has invoked your function, the function has run 10 times. You can actually see who fired that invocation request, how long has it executed, what is the name of the function. All of that is available to you using these metadata objects that you can query. Coming to the API limits. So for whenever you get functions enabled on your org, we allocate like 235,000 additional API calls to be used by functions alone. So you need not really worry about hitting your org limits. Your org APIs are going to have separate limits, and the APIs invoked from functions are going to have separate limits. So at a very high level, that is what I wanted to share. Um, and we are almost at time. So what I'm going to do is I'm going to like stop sharing and look at questions that you might have.
Yep. So one question, Aditya, if two developers are working on two different projects, can first dev be able to pull the source of second developer? As you said, it is connected to a VS Code project, or we should use the version control system.
You will have to use version control for this because it is tied to projects. Like you can't pull the information from one project, deploy it from another project. So that way it will create two clones of your function. So the same function will be deployed into one compute environment and to other compute environment that your project is using.
Okay. The other question is in terms of creating function using Node.js, how secure would be Salesforce org and Salesforce function, knowing that developer uses securely flawed npm package in the heat of the moment?
So the connection that is established between functions, compute environment, and your Salesforce org is secure. So that you need not worry about. The npm packages that you install, you will have to have due diligence. I mean, the only way in which the npm package can get access to your org's data is using the context and the data parameters that are there. So in fact, your function is going to use those parameters in order to get the information out, and those npm packages are going to use the data that you supply to those packages. Now, if you choose to supply your session ID to that npm package, you have to trust that package good enough that they are going to treat your session IDs with care.
Yep.
So which is why if you see the PDF example as well, I'm getting all of the data into my function. I'm only using the PDF maker in order to create the PDF. I'm not asking PDF maker to query data on its own. I'm supplying the data that it needs. So that way you will have to ensure security for the npm packages that you use.
Okay. The other question that we have is Salesforce function is same as concept like what AWS has with one of the functions called Lambda.
Yep, like I told you at the beginning, Salesforce Functions is a flavor of functions as a service within Salesforce environments. Functions as a service in Amazon is called as AWS Lambda. Functions as a service in Salesforce is called as Salesforce Functions.
Okay. How many computing environment max we can have for function?
You'll have to talk to your AE for that. I'm not aware about any limits that are there about the compute environments. So there are limits based on the licenses that you have that you purchase. So it's a thing that you talk to your AEs. Okay. Any more questions?
Sorry, my internet went off. Yeah. So I was the question that I was seeing is how many computing environment max we can have with one function license.
Yeah, that is what I was saying. I am not aware about that info, and AE will be a better person to answer that question.
Okay. But is it like we get a specific like computing environments for the licenses, or is it like if we have the license for the production, or the same computing environments can also be used in the lower end sandboxes as well?
So a compute environment is tied to your org.
Okay.
So if you have a license for production, yes, there is an ability to enable test environments,
Okay.
and then you can attach those environments to your sandboxes. So you can't use one compute environment in two orgs.
Got it. Okay. I have another question follow up on the first question that we have. So regarding to the using the same function with the two developers. So if two developer deploy the function with same project to the compute or connected to the same Salesforce or
Mhm.
how will it decide which one to run from Apex?
So you can't deploy two functions with the same name to the same compute environment. And the way you deploy functions is also by committing it to Git. So it's not like you have an SFDX project and you just run deploy. So on your Force app folder, let's say you write an LWC, you change a line of code, and then you right click and say deploy. Then it gets deployed. But functions is not like that. You'll have to first commit it. So it knows what is the commit history for that, and it only deploys based on that. So like you've in the slide, if you remember, when deploying, the first step is to commit, and the
Commit.
second step is to deploy.
Okay. So we have another question. Can we use function to develop app exchange app? Example, we need a Node.js code which will connect with Salesforce and other database like MySQL.
Um, I mean, your function can do that. In the context of ISVs, how are you going to manage that is something that I'm not entirely sure.
Okay. But is it one of the allowed for the ISV packages? Salesforce functions are allowed, right?
I'm sure they are, but I don't know the
Okay.
details for that, so I can't comment on it really.
Got it. The last question that I have, whether the governor limits can be exempted during by using functions.
That's a good question. I wouldn't say all the limits. There are a few limits that you can get around, but a few limits you can't get around. For example, you query for records using the socket query in the context of your context.org.query.
Okay.
Then the results that you get will be bound by that 50,000 limit. If you want to get more than those, you can always call the bulk APIs, because you have the session ID with you and you have the org endpoints. You can make calls to the Salesforce APIs in order to get more information. Because it is Node.js, whatever information bulk API is returning, if it's in a zip format, you can unzip it and look at the data. Typically, the limits that are relaxed are around your computation time, resources that are used, and so on and so forth. Certain
Uh,
limits do apply. For example, whenever you're using the unit of work, in the background, it uses the composite graph API. So composite graph API limits apply to that unit of work instance. So typically things like that.
so it's something that when I was listening to the session, I had come like I had thought in this. So this we can run as a us, right? So can we invoke async uh, resources available in the Salesforce platform like batch queue from function?
I am not sure why you would want to do that. I mean, when I say functions run asynchronously, that means your Apex code doesn't wait for a response from a function.
Function,
Your
yes.
function runs on its own, and then whenever it has a response ready, it then invokes your callback method. So your Apex is not waiting for a function. That
Got it.
is what I meant when I said asynchronous.
Ideally doesn't make sense. Okay.
Yeah.
Yeah. Yeah. All the questions that we had. Yep. Anything else from anyone that you want to ask, or we are good to wrap up? I'll give it a minute. Can we get access to the PPT,
Yeah.
Aditya?
I will share the PDF with uh, the group leaders and then they can share it with you.
Yep.
Rahul, will you take care of it?
Yes. Yes, Aditya. Aditya, we wanted couple of people wanted to have that Telegram link. So if you can
Okay.
share that Telegram uh, QR code, it would be helpful. We can keep it on a screen for some seconds, and then if someone wants to get into it.
Yeah.
Yep, here we go. So people who were asking for the Telegram link, here it is. So Aditya, once again, thank you for accepting the invite at very short notice and coming to Bhubaneswar Developer Group. I'll be posting this whole recording in YouTube channel that we have, and so that everyone has an access of this session. Thank you.
Yeah, there are a lot of other videos on functions,
Hmm.
so that you can already take a look at.
Okay, sure.
So yeah, thank you, Rahul, for inviting me to the developer group and presenting. You've been following up for some time, but
Yep.
glad I could find time to do this for your group.
Yep. Thank you, Aditya. I think, yeah. Okay, we'll be announcing social media results tomorrow. People who are waiting for that. But yeah, thank you, Aditya. Thank you, everyone. Thank you for
All right.
joining.
Thanks, everyone. Bye.